Okay, in this brief video we're going to take a quick look through the signal path, or at least the radio signal path of this TenTec 1254 shortwave receiver. That's kind of the basic block diagram. We're going to walk through a little bit through kind of where the antenna goes in here, goes into the first mixer. We'll take a look at the signal as it goes into the radio. We'll take a look at the LO signal. We really won't be able to look at the signal much through the crystal filter. It's a pretty low level signal at that point. We'll look at that though again as at the second LO and the IF coming out of that. Look it through the IF gain stage and then after the detector. And we'll just see what those signals look like as we work our way through. So here's the radio here on the bench opened up, and we'll go take a look at that. And we could even peek through the schematic of where things are here if we want to go through there and see where we're poking around. The signal is being generated up here. We're going to use a 10 megahertz signal here that will either be unmodulated or we'll put some AM modulation on that. We can turn that on or off. And we'll start off by taking that signal and bring it down into the scope. So if we look at it here on the oscilloscope, I can see the signal right here. And with the scope we can actually tell it to go measure what that frequency is. So we can actually see it's pretty close to 10 megahertz. And if we turn the modulation on, okay, there's an amplitude modulation of that signal. In fact, if we slow way down, we can actually look at the modulated envelope here. And let's play with the triggering a little bit, and there we go. There we go. So there's our modulated signal. We can actually see it's about a 1 kilohertz amplitude modulation. Again, if we speed things way back up again, okay, there's our let's see, let me adjust my triggering here and turn the modulation off. There's our 10 megahertz carrier again. So that signal we're going to take out of the scope here and go into the attenuator here. Okay, and then the output of the attenuator we've got going into the input of the receiver here. Now on the receiver, if we take a look at this, this is our input bandpass filter. This is going to serve to eject images that are above the LO that would appear into the first IF. That's the main function of this this filter. We see here these two variable inductors here, and the crystal sitting right below it right there compose the first IF. This is a dual conversion receiver. The first IF is at 45 megahertz. Okay, so we're going to take that IF. That's going to be presented to I'm sure let's kind of back up here. The first mixer is actually inside this can. Okay, so that takes the local oscillator coming from one of these two oscillators here. That gets put in here. Our RF signal gets put into here. This is our first mixer. That the output of that mixer is going to land in this 45 megahertz IF that's composed of this tuned circuit. And then just behind here, that little guy right down there, that's a dual gate FET. That's our first IF amplifier. Okay, that amplifies the signal from this IF and drives the second mixer, which occurs right here. So this is this classic diode ring mixer. Okay, there's a second local oscillator with this crystal right here, and these transistors right here form that second local oscillator that's at 44.545 megahertz, which is actually 455 kilohertz different from the IF, which means we're going to get an IF output at 455 kilohertz as presented through this 455 kilohertz bandpass filter, and then goes in through this IF strip to give us all of the gain at 455 kilohertz. And then coming out the output of the IF chain here, which has got some AGC surrounding it, we'll be able to look at the 455 kilohertz IF and then the amplitude detected output here. So let's take a look at those signals through the signal path. So we'll take our scope probe and hook it up to the scope here. Okay, and let's see, adjust the scale a little bit here on the scope, and let's start off by, well, probably right about here. Let's start off by looking at, we looked at the input signal to begin with. We really can't look at the signal as it comes into the bandpass filter because it's going to be very low. So we know it's there because we looked at it ahead of the attenuator. So what we'll do is let's just verify what the IF is. So we said that the first IF is going to be at 45 megahertz. So we're looking at a signal that's at 10 megahertz that we can see here. And we're doing some high side mixing here, which means in order to make a signal land in the from 10 megahertz and have it land at 45 megahertz. That means that our LO here is going to be at 55 megahertz. So there's a little test point here to actually look at our LO signal. And if we go look, I just put the probe on that test point. We go over here and look at the scope. There we go. We're basically right at 55 megahertz, give or take a few kilohertz here. So that's our local oscillator. Because the receiver, if we take a look at it, it's upside down. You can see it's tuned to 10 megahertz. So tuning that to 10 megahertz makes the LO land at 55, so that our IF signal lands at 45, which will put it in the filter. For example, if I tune this to another frequency here, let's kind of scoot this up. Now we can go see that our LO frequency has changed. But let's go change that back down to 10 megahertz. Let's see, right there. Here's our 10 megahertz, and we're right at 55 meg. Okay, so that first LO, 55 megahertz, is mixing with our input signal at 10, creating an output signal at 45 megahertz that's landing in this first IF chain. And again, we've attenuated the signal going in here, so we're really not going to be able to see it. So the best thing to do then is, okay, we've got that signal coming in, and let's kind of look at where we were looking at that here on the schematic. Okay, our RF input is coming in here, going through our image rejection filter, and this is the first mixer. That first mixer is what's taking the RF coming in from here, and our local oscillator, which comes from these circuits here. It's actually one of these two circuits, depending on what band we're in, will create the local oscillator signal through a local oscillator buffer. That buffer then drives into this mixer. This mixer creates, basically mixes our LO with our RF and creates an IF signal at 45 megahertz that comes down in through this filter. There's the tuned inductor, the two tuned inductors, and the crystal filter, as I showed you on the board. There's our first IF amplifier. Okay, and all these signals are still too low for us to really probe. Plus, this filter is really sensitive to probing, so we'll kind of mess things up there a little bit. So really not a good effective way of probing that. But that output of that first IF is going into this classic diode ring mixer. Okay, the other end of that mixer is being driven by this guy, which is our second LO. Now the second LO should differ from the first IF by the 455 kilohertz, right? Because that's going to create that difference frequency at 455. We can go look at this signal. I'm going to probe this at a point where it's a fairly low impedance point, but it's also not going to be the purest signal. But for the diode ring mixer, it's not really that important. So we go back down to here into the board. These two transistors that we see here and here, that's these two transistors here and here. I'm just going to probe the emitter of that upper transistor there in that cascode stage. And if I can get in there, do it and hold the camera at the same time. So there we go, I'm kind of probed right in there now. And if we go look at this thing here on the scope, okay, so we can speed this up here a little bit, okay, so we can see that signal. It's not the most linear thing for a couple of reasons. I'm not probing the best point in the circuit. Also, the ground lead is a bit long for these higher frequencies that I'm measuring here, but we can just get the point. In fact, if I go touch the ground lead and move things around, I can make this kind of change a little bit, but we won't do that. But the whole point is we can actually just see the frequency is 44.545 megahertz, which is actually 455 kilohertz off of the IF, which means the difference frequency coming out of that mixer now is going to be at 455 kilohertz. Okay, so we can go back to our circuit here. Now instead of probing that spot, what I'll do is I'm going to pop my little clip lead off the end of my scope probe here. And what we can do now is start to go down into the IF. Okay, and what we'll do is we'll pick a spot here in this IF, probably this IF output right here at 455 kilohertz. Okay, so what I'll do is we're going to have to slow the scope way down here. Okay, because we're going to be looking at something at about 455 kilohertz. So let me go down here and see if we can probe right down here. Okay, and so now I'm probing right at the output of this IF. Okay, we can kind of barely see that in here. We look over at the scope now, and we can see it's 454.59 kilohertz. That's pretty close to 455. Okay, but we can actually see that IF output. Now that's actually the 10 megahertz carrier that we've got coming out of here that has been converted to 45 megahertz and then to 455 kilohertz. This has all still been unmodulated. So what I'm going to do is let me turn the modulation on. I can actually hear it in the receiver here. We go back and probe that spot again. And we can actually see the modulated RF output here. Okay, you can see the amplitude modulation of that sine wave. Okay, I go back up here and turn the modulation off. Oops. I need 3 hands, so I can actually see I'm unmodulated there. Turn that modulation back on, and let's do that here. And go back here and probe that. You can go see that signal again modulated. Alright, now if I slow this way down here, and we'll just kind of play with the triggering here a little bit, I should be able to look at the modulated RF envelope here as well. Let's see. And I'm going to have to play with the triggering here. Alrighty. I need 3 hands. So let's see if we can set this guy up here like this. We'll just zoom in a little bit on that scope screen. I'll set this up while I can use my 3rd hand. Okay. Okay. There we go. So there's our modulated RF output. Okay. Should be able to see that on the scope. Okay. And so that's going to show us essentially what our modulated signal looks like. And then we can also scoot over to our detected output, which should be right here. And let's adjust our triggering, signal level and triggering. And there's our modulated or demodulated output at 1 kilohertz. So that's a quick walk through the signal path of this TenTec 1254 synthesized dual conversion shortwave receiver.